Up until this point, our code has pretty much gone line by line, top to bottom. But loops let us continue our code until certain conditions are met. So we might iterate over lists of items. We might continue doing some work until some exit condition is triggered. There's a lot of reasons to use loops. So we're going to take a look at two different kinds of loops, for loops and while loops. There's good cases to use both of these kinds of loops. We'll also take a look at exiting from loops using the break statement. So our programs are getting a little more complex. So we're going to go to Visual Studio Code. Let's create a new file and let's call it for.py, for.py, because we're going to create for loops. And let's take a look at this code. So in here, we've got, let me shrink down my files so we can see everything. Line 1 will have an array, names equals square bracket, so we're creating a list, Alice, Bob, Eve. So how do we work with the data in that list? Previously, we might use names, look at the index of 0 to get the value. We might look at the index at 1 and the index of 2. But if we're going to hard code those indices in our program, if our list expands, we have to keep modifying that code. So we might not want to do that. It's better to use loops to iterate over the data. So this for loop will let us iterate through the data in that list. So I'm going to write this code for name in names. Put the colon there. Just like at the end of our if statement, we have a colon. Here in Python, at the end of this line that starts a for loop, we'll put the colon. And when I hit enter, Python is going to indent that code. So for each iteration in this loop, what are we going to do? We are going to print hello space plus name. So where did name singular come from here in this print statement? Because in line 1, we created names plural. But here in line 2, what this for loop does, it says, okay, for each of the items in name, take that item and we're going to treat it temporarily as the name variable. Then we can refer to that singular name variable here in our loop. So we could run this code and we see the results. Hello, Alice. Hello, Bob. Hello, Eve. So the first time that this loop ran, the first name used was Alice. So this block of code here, in this case, it's just a single line. The value of name was Alice. The second time through, Python grabbed the second item in our list, Bob, stuck that value into the name variable, and then printed out hello, Bob. The third time, looping through the items in the names list, we got Eve. So the value Eve was stuck in that name variable. Then when we print it out, we get hello, Eve. So we could expand this list and we don't have to modify our loop at all, Dave. No matter how big we make that list, our loop is just going to loop through all of that data. So it could be that list could be 1 million items long, and we wouldn't have to modify the code in the loop. So nowhere in here did we have to use any of the list indices to access the data in those list items. We used a loop to go through them one by one and do something with it. So a loop challenge. Let's see if we can apply this slightly differently. I'll walk through this with you. I'm going to close for.py, expand my Explorer so I can see my files here. I'll create a new file called for_nums.py. So in the first line, what should we do? Create an array of integers. Name it whatever you want. Nums equals 1, 2, 3. In this case, I'm using the word array loosely. The exact Python type is a list, but it is an array. In the second line, we'll start the for loop. For num, I can call it whatever I want to, for x in nums, colon, print x. Is this code going to work? Should. Let's run it and see. I get 1, 2, 3. Perfect. Fairly simple. I just need to make sure that this x here matches how I'm using it later on. Singular versus plural, it's just a convention. So with lists, I like to make them plural because it shows they can hold multiple values. But when I'm iterating through those items in a list, I like to use a singular noun there. I just need to make sure that they are synchronized. So this code also should work, and it does. So fairly simple, but that's how we would iterate through a list using a for loop. So become very useful very soon, I promise you. A different kind of loop is a while loop. So I'll create a new file, call it while.py, and let's create that code. So counter equals 1, so that's a variable that's just holding the integer value 1. While counter is less than 10, so notice this is a comparison statement. This is going to evaluate to true or false. So as long as that statement is true, this loop will keep looping. So what should we do here? Let's print counter. Then I'll say counter equals counter plus 1. That's going to be a really important line of code. Now here I'm going to delete those spaces to exit that while block, and I'll print done. So let's run this code and let's take a look at what happens. So I get the output 1, 2, 3, 4, 5, 6, 7, 8, 9, done. So what happened here? The program started at the top. We created our variable. Then in this while loop, it says, okay, is counter less than 10? When the program started, counter had a value of 1. So this is true. Because it's true, Python's going to run the code in this block. It's going to print the counter, and then it's going to update the value of counter by taking the current value and adding 1. So once it gets here, Python will go right back to the line 2 to that while loop, and it's going to check. Is counter less than 10? Well, now the value of counter is 2. That is still true. So it runs the code again in this block. It prints it out, then it updates the value of counter to add 1. So it keeps going and going and going. So when counter is 9, 9 is less than 10. So it prints 9, and then it adds 1, so we get 10. The value of counter is 10 at that point. So then Python goes back up to line 2. And it's going to check, is 10, the current value of counter, less than 10? Well, 10 is not less than 10. So that's false. So Python is going to skip us out of that loop automatically, take us down to line 5, and we print that we are done. So while loops are very important. Key idea with a while loop is that you've got a condition, a statement that's going to be true or false. And there could be multiple. It could be while counter is less than 10 and name does not equal Alice, something like that. We could make this expression as complex as we want, but it has to return true or false. What would happen if we forgot line 4? What would happen here? This is really easy to do with while loops. This is why they can be not dangerous, but we have to pay attention to what we're doing. Lots of people coding the first time might do something like this. Counter equals 1, while counter is less than 10, print counter. What's this program going to do? I'm going to run it. Hopefully I don't crash my machine. If I run this file, it's just printing 1 over and over and over. So to quit, I'm going to click down here in the terminal, Control C to stop it. And it tells me where it exited, but I just got, thousands and thousands of the number 1. So this loop did exactly what I told Python to do. While counter was less than 10, is printing it out as fast as it possibly could, because I never actually changed the value of counter. So that I introduced a bug after writing the correct code. So really important to make sure that you can exit that while loop. Let's see if we can do this challenge. While launch.py, that's the file we should make. So I'll create a new file, call it while underscore launch.py. We want to create a blast off, a countdown. Go from 10 to 1, and then we should print blast off. Okay, so my start number is 10. So what's the condition here? It could be a few different things. While start is greater than or equal to 1, that would work. Or we could say while it's greater than 0. They effectively mean the same thing for the logic of this code. I'll print start, which is, the name. We're updating it, so it's not maybe the best name for a variable, but it is what it is. It works fine. Now we have to reduce that by 1. Start equals start minus 1. And then I'll delete that indentation because at the very end, once we break out of that loop, we want to print blast off. So let's see if my logic is correct. Let's run this code. Fingers crossed. Good. So I do start at 10. It goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That last check, start is equal to 0. So start was not equal to 0. So I broke out of that while loop, not wild loop, the while loop. And on line 5, it prints blast off. Let's create another file called break.py. Break.py. Because our programs are getting longer, we got to use the Visual Studio Code editor here. We'll create a list. Alice, Bob, and Eve. For name in names, print name. Okay, this is what we did before. Let's just make sure that this code actually works. Alice, Bob, Eve. Good. But now let's modify this a little bit. So if the name is Bob, we just want to exit out of this loop. Like maybe that's what we were looking for. We were doing some kind of, we wanted to search this list until we found something and then we're done. So we can put a check in this block of code. If name equals, because we're doing a comparison here, so we're doing an if statement, so we need this to be true or false. If name equals Bob, well then what do we want to do? Make sure we put that colon in there. We want to break. What this is going to do is just going to jump out of that loop. So when I run this code, what's going to happen? Try to think, before I even hit play, do we know what's going to happen? We should know what's going to happen, hopefully. If we're learning, that's fine. If we're not quite sure, we can test this code. I'm going to hit play. What do we see? We only see Alice. So the first time through the loop, the first name was Alice from the names list. It did a check. Does the name equal Bob? No, it was Alice. So we just skip that. It prints Alice. Second time through the loop, name is Bob. So we do a check. If name equals Bob, we break. So we jumped out of that loop before we even got to that print statement. And because we jumped out of the loop, we never even got to Eve there. So that worked just fine. We can use the break statement with while loops. Let's create another file to test that out. And we'll call this repeat.py. We're starting to combine some of the other elements here. So using input here, answer equals input. So we're prompting the user. Guess my favorite color, colon, space. That's going to create a nice input for us. So while true, so how long will this loop go for? Well, forever, unless we break out of it manually. Because we're not comparing two variables now. Now we're just hard coding the Boolean value true. So if answer, so that's a string data type, and because people might enter capital B for blue or lowercase r for red, whatever it is, we'll just make this lowercase to do a quick comparison. Equals blue. Blue is my favorite color, so we're just going to put that in there. So again, with our if statements, we need to end that with a colon character. We will print correct. And then we will break. So this will jump out of the while loop. That's the only way we exit this loop here. But what if they didn't guess blue correctly? We'll have the else. So they didn't get the right answer. So what do? We'll recreate that answer variable with new input. Nope. Guess again, colon. All right, so let's take a look at all that code now. I'm doing just a quick visual debugging check. So I'm going to get the answer variable will be set by the time we get into that while loop. So it's going to check if I make it lowercase. If it's blue, it'll print correct and break. Otherwise, this will continue forever until I guess blue. So let's try running this. Play my code. Guess my favorite color. Red. Nope, guess again. 42. Nope, guess again. Green. Nope, green. Nope, green. Yellow. Cyan. Magenta. Blank. Space. Exclamation point. Until I type blue, this program will keep running through that while loop forever. But if I type BLUE, weird case, but the program's sophisticated enough to account for that, if I hit enter, it tells me correct, blue is the favorite color. So while true is a convention, if you just need a loop to keep going until some exit condition is triggered, while true can work effectively. But you got to make sure that your logic is sound, that you're actually triggering that break somewhere. Because if I forgot that break, what would happen? Let's introduce a bug into our program. If I get rid of that break, what happens? I run this code. Oops. I should have clicked in my terminal before typing my input. Red. Nope, guess again. Green. Nope, guess again. All right, blue. Correct. Oh dear. I got stuck in my loop. Now it's just printing correct thousands of times. This is no good. My program is going to crash my computer. What do I need to do to stop this? Because it's gone haywire. Control C to cancel it. So that was no good. No good at all. I need to have that break statement in there. So this is useful. I would encourage you again, take a look at the loops. Take a look at creating some of the loops. There's a couple of examples of using for loops, a couple of challenges using while loops. See if you can write the code that implements those loops. It'll be good practice.